All right. You guys had enough cake ready to rumble? Yeah, you missed the cake. Sorry about that. So, my name is Lars Jankowski. If you don't know me yet, you will learn a lot about me. No, don't you worry, I will not actually bore you with my history. You can read everything up online, and I'm here today actually to tell you a fairy tale. Over the last 20 years, I had a lot of fun with being interim CDO in many, many companies where VCs or founders called me when the situation is massively fucked up, and they tell me, hey, Lars, please, can you help me? So I thought, this is a really good idea. Let's do a talk about that and about what could have happened. So please remember, everything I'm going to tell you is complete fictional, it's just a fairy tale. You guys are developers, and I am pretty sure you think you have seen everything. Yeah? Who of you thinks you work in a company which a really, really bad situation and where the code should be much better? Come on, I want to see some hands. Well, a lot. Okay, let's say 50%. Not too bad, actually. That means the other 50% must be really happy. Okay, so the bad news is you have no idea. I can really promise you, after this talk, you will understand a lot more what means a really bad situation. You really have completely no idea how bad the situation could be. So, let me tell you a story. In a galaxy far, far away, I've been called into a company, and they asked me hey Lars, please help me. So I thought let's see what is the situation, what do we have? So what we had is, we had daily frequent crashes. I mean, every day, a couple of micro outages. Well, could be worse. We could have longer crashes once a week. I thought okay, that doesn't look so good. And also, we were talking about a website which had many million users a month. So we're not talking about a small web page. We are talking about a web page with a lot of traffic and a lot of pressure. And for sure, we had 2.4 million lines of code. So 10 years, roughly, more or less, of development, 2.4 million lines of code of PHP and HTML. So this is going to be awesome. And we had a database which had, just to give you a couple of numbers, on average 3,000 reads per second and, 2,000 writes per second. That's the average. The peak was 3,000 reads per second and 2,000 writes per second. So I think that could have been improved. And wait a second, it was MySQL 4 and PHP 4. MySQL 4, PHP 4. What the fuck? I mean, we're talking about this century, not about 1990. I think PHP 4 wasn't supported since 2007 something. And we don't have to talk about testing, no, for sure no tests. 6 developers and around 6,000 open bug tickets in Mantis. And we had an awesome management, actually, who told, and I actually personally overheard that, told the developers, you, sir, actually in German they said, Sie, you are not here to think, you're here to do exactly what I'm telling you. And that actually was the moment where I thought okay, I'm seriously fucked up, and I need support. So I called my friend Thorsten, welcome him on stage, and actually said, Thorsten, you gotta help me.
Yeah, I got a phone call from Lars, and he said, well, I have a problem. And yes, I'm doing PHP and web development for 15 years now, just a little bit shorter than Lars. And so I said, yes, why not? Let's do the funny things.
Yeah, and I tell you, it was really a lot of fun. We had so much fun with source code, I tell you.
Yeah, the funny thing was, it was partly mixed German, English, and do you see the SQL injection here? Okay.
I mean, if you don't see it, you should go and stand in the corner, actually.
But it was a little bit secure because it just used post, not get.
So it could have been worse. So really, like, oh my God. Oh my God. But the really good thing is, guys,
Yeah, the good thing was we never saw errors because of that.
yeah, there was no errors. I mean, why shouldn't you have errors? And okay, let's talk a bit about the physical situation. Each engineer had his own room. Yeah, so he really is sitting on his own desk, a small cubicle, not cubicle, real room, and working there.
Yeah, and the best thing was every engineer has its own real phone. Who has a real phone at his desk here? Oh, some people.
Oh, guys.
Is it ringing all day because of the 6,000 open bugs?
It was really not a good situation. And for sure, there was no team lead. Why would you need a team lead? I mean,
Yeah, or why do you need a software architect who takes care about your infrastructure and your software?
and that was really an interesting experience. The BI and the metrics have been completely confidential. Which, think about it, you are running an e-commerce website or a social website or whatever, and the orders per day or the users per day are confidential to your team. That is not really a really smart idea if the team should get any clue what's going on. I mean, they changed something. Is it now more, less, better, worse? No idea. So that's something which is not the smartest move if you really want to buy into your team.
Yeah, and another good thing was the support was not allowed to talk to the engineers. So if a customer had a problem or found an issue, the support couldn't tell the engineers that there is a bug.
And I needed 3 months to figure that out. Nobody told me. Really. Until by accident I stumbled over it because two of them were talking while having a smoke. And then I asked, like, why didn't you tell us? Well, no, we have the clear rule, we are not allowed to talk to you. Yeah.
Yeah, and I hope you can see it. There was a German dialect even in the source code.
Well, why? That was just a special PHP dialect. And then we thought, like, oh boy, this is going to be fun, really. I mean, version control. Why would you need a version control? Real man, remember the test on production.
Yeah, and the whole application was one monolithic monster. So all the 2.4 million lines of code did everything. It was front end, back end, it was CRM, it was CMS, everything.
And this is the most amazing thing. The application only runs on the production machine. So, how do you test? How do you develop? It doesn't work on your local developer machine. There is no stage. So you have any idea how you would do the development in such an environment? Anyone? Come on, guys. Make an educated guess. Welcome to production server. Yes, exactly.
Well, it was quite easy. So every developer copied the whole code base with 2.4 million lines of code into his own development folder. Maybe sometimes a developer had 2 or 3 folders, and as we said, we were 6 developers. I think there were maybe 12, 15 development folders all the time with different code bases, with all the 2.4 million lines of code.
And that was for sure a really good, smart idea, because if you develop and you debug on the live machine, that also contributed a little bit to the daily outages, for sure. And then, I mean, we talked about merging manually. So once a feature have been developed, then actually it was merged.
Yeah, and yeah, all source code And all media files were distributed by NFS, the Network File System.
Oh, and I remember the charset was Win1252, which was actually surprising given that all the developers were decoding on Debian machines. And till today, we have no idea why it is Win1252. Again, let's get back to NFS. Anyone, come on, tell me what's the problem with NFS? The latency, yes, that is actually a good idea, but that's not the real problem. Come on. Pardon? Timestamps, no, also not. Hey, let's cut it short. Thorsten, maybe you want to tell him?
Yeah, just for example, if a read process is locked on one machine, the other machine is also locked, full with file system.
Yeah,
so
when the
everything is locked then.
When the mount target doesn't work anymore, the servers where the mount is mounted into, they just stop with a CPU load of 100%, which means if all servers, for example, mount one machine, because they read, if that machine hangs, all servers hang. And I mean really hang, there's nothing is going on. It's really very bad.
Yeah, another example of awesome code.
So we are going actually to highlight our talk a little bit with showing you pieces of actual production code.
So this is a good thing that you can override get variables in PHP.
And that's why PHP is awesome. Okay, let's talk about architecture. Software architecture, for sure, the software architecture has been awesome. Yeah, still. So what they had was a master-slave setup. And everybody, I remember very well, we're sitting in these meetings, everybody was talking about the master-slaves, master-slave. I think like, yeah, master-slave. But I got a slight weird impression because from what they were talking about, I saw like, something weird is going on with the master-slaves here.
Yeah, we found out after some months that the slaves were actually the front-end servers and the master was the back-end.
It's not like what you would think what master-slave is. I was like, really, I was like, seriously? Hey, what? Well, we were still laughing. Yeah, okay.
Yeah.
So we had like 2 masters, 14 slaves, just that you have a rough idea.
And we have something called the optimizer, nicknamed the Opti. The Opti was a very big machine which indexes and copies all the database contents and even the whole database files from the master to the Opti, and then runs about, I think, 15,000 lines of SQL scripts to optimize the database to make it more readable and to improve it for read performance. And then copy the whole thing to the front ends, or the so-called slaves.
And the indexing took up to 36 hours. The interesting thing is, I mean, that's actually a smart idea. If your data is not read optimized, you just like convert in something read optimized. I think Magento is doing the same setup, not getting very well along with high-load web pages. But anyway, so if you do that, you can do that. I mean, you could also fix your data layout, but that would require a little bit more thinking. So the optimizer used up to 36 hours. And now think about it. We're talking about a major e-commerce website. 36 hours with delay between changes in the back end and the front end. So let's assume you have like a price change.
Or stock change.
Stock change, product is not available anymore. I mean, come on, waiting 36 hours, it's not too long. That's absolutely acceptable, I would say.
Yeah, one very great thing was it wasn't not even MySQL 4.1, MySQL was even patched. It was patched to create a procedure to read or to create a read-optimized category tree. The problem was the procedure was called procedure analyze. If you're looking into the MySQL documentation, the example procedure is called procedure analyze.
It had nothing to do with analyze, for sure. It was just like Again, it could have been solved by, just to make it clear about what we're talking here, the category tree was stored as a parent-child connection, which is obviously everybody of you should know that this is not really fast to read. Yeah? You could have converted that in a nested set because it supports a lot of read, just few writes, works perfectly, or you can patch MySQL and you can invent an optimizer. You can do that. And the search also was built upon MySQL full-text search, and therefore every table was MyISAM.
Yeah, but the best thing was, in the database, there were 100 million search terms. So I visited a MySQL developer conference some years ago, and a smart guy, I think from Ukraine or Russia, who built the MySQL full-text search some years ago, he said, yeah, MySQL full-text search works with 100,000 terms. He was wrong.
Right, it works, yeah. And a search for term black took roughly 45 seconds. And if you did this twice, that was more or less a denial of service attack. Luckily, user didn't search so often for black. MyISAM is just awesome. That's what we thought, like, yeah. So the problem with MyISAM, anyone knows what cascading logs are? Come on. I know a couple of you know it. Most likely you are sleeping. That's just one. Okay, it's as simple as that. MyISAM table log. You know that, yeah? Okay, so if a process writes, table is logged, waits, and then the next process can write. So that's the theory. But what happens if you have many, many thousand writes per second? Remember, 2,000 writes per second peak, yeah? Could have been more, hammering the database. So what happens? You have table log, the next process can't, and then already 10 more are adding up and adding up and adding up, and it's just piling up. And in the end, it just stops. So you can wait as long as you want, at least with MySQL 4.1. It will never get better. The database just hangs. You need to kill all processes. And that was one of the reasons for all these short outages, because sometimes it's just like the cascade, we're growing too fast, and then buff, that's it.
Yeah, and the copying of a MySQL database took 12 hours. So it took 12 hours to copy the content from the backend to the front, from the optimizer to the front end.
So 36 plus 12.
Yes.
For product updates. And for sure per NFS. And because of the file copy, we just can't easily migrate to MySQL 5, because actually the file was physically, the MyISAM data file was physically copied, which means you need first MySQL on the front ends, then on the opti, and on the master backend. Yeah? So that's not that easy.
Yeah, and once again, think about NFS, because when a copy process hangs, the whole system hangs.
And we're talking about huge files, really huge files.
Another example, we called it Christmas tree programming. I think you can look at it for minutes, and I don't know what it's doing.
It's instant meditation for a developer. And actually, when we prepared the talk, we both were discussing and we're trying to figure out why that has been used and where, and we couldn't come up with. I mean, it was in production, but nobody knows why. We had two administration interfaces, an old one and a new one.
But Lars, the best thing, both were used in production. Really.
And one was called admin, and the other one...
Yes, and the new one was called beta, because it was beta in production.
Often. And talking about service-oriented architecture, the accounting has been done fully by themselves, and I needed over 1 year to find that actually, and have been developed in an Oracle system which was completely locked away. So no developer had access to that system. Nobody knew what was going on, just like some data pulled out of MySQL and some invoices fell out for the Datev.
Yeah, another great thing was all media files were in one directory. So the page isn't that small. And believe me, do not an ls-la on 3 terabytes of images in one directory. It takes hours, really hours.
And now, any idea what I want to mention now? Yes, thank you, Thomas. The machine was mounted by NFS, so for sure we did an ls minus dash LA, and then we just like took down the whole site. It was like, oh shit.
When he said, oops. A very good thing was all servers were self-assembled, so no cloud infrastructure or
like any manufacturer hardware, they just built them themselves, and for sure they have been extraordinarily reliable.
Yes.
And talking about the hoster, I don't need to mention that hoster had a tendency to reboot the wrong machines. And seriously, you called them because the machine was hanging, you called them, please reboot
Slave 7,
and it just rebooted a random machine. I think nowadays this is used in production for testing. I can tell you we failed the test.
And think about it, what happens if, for example, a copy process is running on an NFS and you're rebooting the machine by accident? Yeah, it was clear nobody wanted to touch the code because it just grew all the time, and nobody wanted to touch the system, which was really awful.
Oh, Thorsten, that reminds me, you remember the kill script?
Oh yes, one of the best things.
Oh, I have to share that, sorry about that, because that is awesome. So, if the servers are overloaded, the CPU is 100%, and your machine is not reacting anymore, what do? Come on, suggestions. Huh? Okay, I see you're all a little bit tired. Let's make it a little bit easy for you. They invented a kill script, which actually has been triggered once the load was too high. And that kill script just killed random processes until the load, the server was reacting anymore. And you guys laugh, but I tell you, actually it works. The servers stay responsive, and you can actually access the servers and work on them. But for sure, I mean, killing random processes.
It could be an Apache process, it could be a MySQL process, or the NFS process.
So actually, the hat gave us a little bit a feeling of some own awareness of the system. It had its own mind. Some weird things happened, yeah, when you did something. So we just thought, like, what the fuck? This is going to be fun.
Yeah, and we found some critical errors too.
I mean, okay, it was PHP 4, you can't use exception handling, yes, but yes. That was a really sophisticated error logging, I tell you.
And you see in the to-do message, add some Smarty code here. Smarty was the template engine, and for sure it was patched.
So, Thorsten, this is going to be fun, right?
Sure.
Yeah. I can tell you.
Yeah, it's easy, because what was one of the biggest problems were just MyISAM, and yeah, it's easy just to change MyISAM to InnoDB.
Yeah, but sorry, Thorsten, what if I told you it's not so easy, because remember, MyISAM, file copy, patched version, and let's not forget, you have in mind no stage and no local testing, so you just cannot convert a table on production to InnoDB while the servers are hammered and just see what's happened. I mean, you can do that, but I think that would be even a worse idea.
And one big problem is you cannot do file copy anymore with InnoDB.
Right, that's also true. So let's talk a bit about, okay, so now you have an idea. I think really that is, and please come to me later if you seriously believe you can think of anything worse and tell me. I'm happy to listen. But from my experience, this has been really the worst case. So how did we solve it?
Yeah, we started very simple. We just deleted Mantis completely. And even all 6,000 bugs were gone.
Yeah.
And we did a fresh start with Jira. And very surprising was most of the 6,000 bugs never came back again. So I think we couldn't be that much important.
So, and I really like, Christian, what you mentioned. This goes in the same direction, just like, don't give a crap. People will really show up more often if it really hurts them. So we just deleted the bugs and that's it. And, I mean, we introduced GitHub. Version control. The good thing, and now the really good thing, is because these guys never ever used a version control. They also had no weird ideas about how to use a version control because they were used to CVS or Subversion or whatever. They could learn it from scratch with Git.
And it worked very, very good.
Yeah, absolutely. Yeah.
So yeah, the next thing was just rewrite all the code because it was so awesome, so awful. So yeah, just throw it away and do everything from scratch.
So we did not lose our humor, and we had to laugh a lot because otherwise we wouldn't stand here actually. But talking about the rewrites, I can tell you that's not really a good idea, rewriting. No.
Maybe the older ones know the competitor of Excel called Quattro Pro from Borland. Is anyone still using Quattro Pro? I don't think so. Or DBase, it was the Access one.
Thorsten, this is a generation issue.
Yeah.
We are just too old for these guys here.
Maybe one or two are old enough.
No, but seriously, so you don't know these because all these did a rewrite, whereas the competitor, like Excel, favored refactoring. And why it's so bad with rewriting? It's simply because first, you lose all the know-how. I mean, 2.4 million lines of code is really awful, 10 years. But on the other hand, look, there's 10 years of know-how, small bug fixes, features, and so on. You never, ever can catch all of them and rewrite them. And secondly?
Yeah.
Huh?
You should never do it.
Yeah, no. No, it just takes too long.
Yeah.
It just takes too long. Rewriting, you just can't wait a year to rewrite everything. I mean, there are famous
2 years.
Or 2 years. There are famous examples. Company, I won't mention any names, who rewrote their application, and just like 1 year of no innovation and no movement, it's not just acceptable nowadays because your competition is going to overtake. So, what happened? Yeah.
But yeah. What you still have to do is, but not all developers can work on refactoring because, for example, if you have legal issues, you have to fix something, or that can ever happen.
Yeah, right. And also, you also have critical bugs which have to be fixed. And I mean, clearly, yes, we deleted 6,000 bugs, but still 1 or 2 bugs were left and have been. And really, they had to fix them.
Yeah, and even sometimes you need even small new features, because if these small features have a very high return on invest, you should do it because you get money from it.
Yeah, and management had a clear opinion on what these kinds of features were and how important they are. Yeah. So it's quite simple. We need to hire more developers, and we hired a couple of kick-ass developers and split responsibilities. And I can tell you, you would think it's difficult to hire people for PHP 4, MySQL 4 website with a lot of old code. No, it's not, because actually I sold it in the right way. What I sold them is like, look, we are going to refactor that massive beast. Yes, it's old code, but we are going to move it into a golden future. We're really doing it. And meanwhile, there's a lot of traffic, millions of users. So it's like doing a surgery on the open heart. And actually, that has been quite attractive for these developers. Some of them are sitting here. You can ask them if they're still happy.
What's also very good is you can learn how to do it not.
Yeah. And it has been fun. So first, team worked on refactoring the old stuff. So we built teams.
Yeah, the second team worked on critical bugs on the old code base, and, for example, worked on minor features requests on the old code base. And all these feature requests were also merged to the refactored code.
And the third team worked then on the new stuff already in the future based on a service-oriented architecture.
Yeah, and yeah, what we did was also we exchanged the members from the teams after some weeks. So everyone had to work on the on the refactoring. Everyone had to work on critical bugs, for example, or minor feature requests, and everyone was allowed to work on the new stuff.
And that's really good because of two things. First of all, you really enforce collective code ownership. And secondly, there are not just a few poor bastards who always have to work with the old code. Yeah? Everybody takes his turn, a couple of weeks old code, then you get with the new code and so on. That's really also very important for the team spirit because it's a team, massive team invest of energy and mind to refactor that.
Yeah, and what we also did was we changed the team size according to the needs. So if, for example, there's a very big critical bug, we increased the team for the bug fixes. Or if we need more people on refactoring, the refactoring team was increased.
So what have been done? How did we start?
Yeah, we started with a so-called config project. The config project was just adding a .ini file. The .ini file, the goal was just to move all hard-coded IP addresses, paths, everything which was hard-coded on production into config variables. Just to make it possible to run it, for example, on a developer virtual machine or on a staging environment.
When clearly we first had to need the capability to run the software locally before we make more changes. And also we tackled the deployment.
Yes. The old deployment was just copying the file on one machine and then everything was done by NFS. We wanted to get rid of it, so we built a very nice deployment with Capistrano, and yeah, we got rid of the NFS infrastructure for the code. We had automatic deployments, fast deployments. I think it was less than 2 minutes. Yep. And yeah, we deployed, I think, 4,000 or 6,000 times now.
So let's do the time warp. And no, guys, I'm not going to dance the time warp here. Thorsten, how long did we need for this project?
The configuration project and the deployment project took us 7 months.
So 7 months just to add an ini file. That's awesome, huh? I think we deserve a little bit of applause. That also, talking about a management perspective, that has been very difficult to sell because that means 7 months, no innovation, no new features, nothing, and for sure we made mistakes. For sure we added new bugs which brought the site down. Yeah? So all the people working there really needed a lot of patience with us, but there was no way around. That had to be done.
Yeah, and we deleted a little bit of code. We went down from 2.4 million lines of code to 1.7 million lines of code.
Yeah, we got rid of one of the admins, and we deleted a lot of duplicate PHP code. Yeah.
Yes, and one hint for everyone, down to PHP log on 2.4 million lines of code, it doesn't work.
So that has been awesome. Thorsten, come on, give me 5. So we really had fun. So finally, I mean, we could run the system on the developer machine. I very well remember the feeling was like, oh, it works, awesome. Yeah. Now we can do the real work. And the real work, for sure, we switched some tables from MyISAM to InnoDB. And why only some and not all? Someone?
Search,
that's
yes.
actually a good point, but the biggest reason was that InnoDB consumes a lot more RAM than MyISAM due to the more complex index. And we converted everything, and then just like, oh shit, not enough RAM. So we focused on the really important ones.
Yeah, and we removed NFS almost everywhere.
We upgraded the front-end service to PHP 5.3. Yeah.
And the backend server were upgraded to PHP 5.3.
And we removed a lot of useless feature. And again, thank you, Christian. I really like that because I had a lot of arguments where we had a lot of source code. I was like, okay, this is this feature, but who is using it? So I tried to figure out in the company who is using it and why it has been done.
Yeah, and useless was defined by us by return on invest.
Yeah, so if it didn't bring any money or there was a feature with a lot of work, like there was one customer where the files have been imported once a month and that took like one developer 2 days of work. And we're talking about like, I think he paid like €100 a year. That's not worth, so we just like, got rid of the customer.
Yeah, and useless also but defined by common sense.
Yeah,
if we found features that doesn't make any sense, we just removed it.
So that was the next big step. Time warp again. Any idea how long we needed for that? Come on, make a guess. Not bad, 4 months. How long?
Yeah, it was 4 months to port all the application from PHP 4 to PHP 5.3.
And one of the side effects, remember our old peak, 3,000 reads, 2,000 writes per second. We went up to 11,000 reads, 35,000 writes per second. By far not as much as Rocket has, I understand, but still for us it was a big deal. And it helped a lot because a lot of the problems were gone. And for sure because of the switch to InnoDB, the small outages were gone, the small or the not so small outages were gone. That's all. I like the importers have been working faster. We also increased the speed of the optimizer, I think.
Yeah, we brought down the optimizer from 36 hours to 4 hours.
Yeah.
So
I mean, still 4 hours is not really good, but a lot better than 36 hours. So that really, really was awesome, and we felt good. But
yeah, we still found these kinds of queries in the code. I don't know how to improve it.
Yeah. So
but it's looking good.
Yeah. So we thought like, won't make us feel happy, yeah.
Yeah. You can do this in PHP, and it works.
So I thought like, okay, the real problems are gone, but no more refactoring. There's no way around. We need to rewrite pieces of the parts of the code. However, we solved the production issues first, so the website was in a state where they could survive, and the customer were fairly happy. So we had to rewrite. So we changed the architecture into a service-oriented architecture.
Yeah, and we rewrote first the front end and search with Symfony 2 and Elasticsearch.
Yeah, so we did exactly what Christian actually told to do, move the whole product catalog into Elasticsearch.
Yeah, we're doing now continuous integration with Jenkins, so all new projects are tested. We are doing code analysis. We're doing everything what everyone nowadays is doing.
And using Vagrant and Puppet, where actually the whole idea is that working together with our awesome hoster who is sitting there, and I'm not saying the name, I'm sorry, we actually convinced them to use the same Puppet script. So we have the Puppet scripts on the developer machine are the same like the hosters. You really can make sure that the configuration is the exact same. So no more, oh, there's a small slight library differences and it works here and it doesn't work on live, on production and so on. You really can roll it out very, very easily.
Yeah. We have one rule. All new projects are built with Symfony 2. Very simple.
And we do know for sure test-driven development with all the new stuff. That's clear. Yeah.
And we already started some time ago. We use the refactored code base from the master code and doing a very slow migration path to Symfony 2 here as well.
So this is now where the really fun starts. Yeah, finally the new stuff. So how long did we need for that?
Yeah, just to remove all the stuff which were attached with the optimizer took us 4 months, and in parallel, we did a rewrite for the front end. It just take 3 months to rewrite a new front end with Elasticsearch and Symfony 2.
So really high performance website now in only 3 months. Compare that to 7 months for adding an ini file. A few numbers which might be interesting if you have a look at the lines of code. So we started with 2.4 million lines of code. We ended up with something like 600,000 lines of code.
That's not true anymore. Last week, someone deleted 100,000 lines of code. He found it.
And we don't need it?
No.
Okay. But really, I mean, it's a lot of functionality. It's the same functionality, a much better website, and much less code. So for sure, it's easier to maintain, easier to scale, and the read performance went up a lot. And talking about Elasticsearch, for sure, a complete different story, very, very fast. So, Thorsten, maybe you want to tell a little bit about the software architecture.
Yeah, we're now having service-oriented architecture. We still have the so-called masters. We still call it master because, on historical reasons. But what we are now having is 2 machines still, but new machines with a lot of RAM, a lot of SSDs, a lot of CPU with PHP 5.4 and MySQL 5.5. So we upgraded this stuff from MySQL 4.1 to 5.5. Very fun. We have a new middleware based on, this is just a Symfony 2 command console application. It's our so-called product server. It's also a master-master application, so we always have a head failover.
So you more or less like normalize the data there in a
Yes.
more senseful.
And we have only 3 front-end machines anymore.
Compare that to the 14 we had in the beginning. And for sure, the web page is a lot more powerful and can serve a lot more traffic. So you could say like that we live happily ever after. But I think we have a couple of minutes left, so I want to tell you the talk is called Company Refactoring. What the non-technical things, which were also quite important. So we stopped the downward trends, visit and SEO ranking clearly. Yeah.
Yeah, we also improved SEO visibility, even with some Panda updates.
Just by switching the technology. And we added new features for sure, added in days or weeks and not months. That's very, very important. Talking about the company, unfortunately, from the 6 original engineers, we had to let go 4. So only 2 of them are with us anymore. But
yeah, we hired 6 new kick-ass engineers.
Yeah, so that was a big improvement also, and even though it's a sad story because we had to let go 50% of the whole company. Yeah, I still think it's a benefit because the company can actually execute much faster. They do the same, yeah. The website, the tools, everything, just by modernizing the whole environment, half of the employees can do even more work. So that is a benefit, even though it's quite sad for some of the employees. And we exchanged the management. Remember, you are not here to think. Meanwhile, that was something where I had a lot of fun with. I had to deal with the management, and at some certain point, we realized that we had to exchange them also. So now the company is from top to bottom changed. Talk about a little bit, what were our learnings?
Yeah, we have a lot of learnings. So refactoring is really, really hard, and you should do it in an agile way. So very small iterations to goal to have a refactored code base in the end.
Yeah. And also, it's very important to remove the useless features first. I mean, identify them, and you have to be ready to fight a few fights because you find always someone who insists on that feature is really important, and you need to actually prove it with data that it's not, and then you can get rid of the features.
Yeah, and rewrite all the things that are completely broken. So something like in MySQL full text search, it doesn't make sense to refactor a MySQL full text search. Just throw it away and rewrite this stuff.
So rewriting, even though I said like rewrite is always more important, some things cannot be rewritten. However, be careful. Be careful, because rewriting is a lot of work. So always try to refactor, and only if it doesn't work, then you can actually rewrite it.
Yeah, and never forget to keep the refactoring, even on the new code, because this is one of the downsides of PHP. The code ages very fast, so you have to refactor all the time. And keep that in mind.
Test, test, test. Well, that's it. Thank you.
Thank you very much.
Do we still have time for some questions? Or are there any questions? Oh, yeah, there.
Thanks for the talk. It's very impressive. But what I really don't get is, why didn't you run away?
Thank you for asking the question. I also wonder myself. No, because I said like I made a promise. I said I am going to do that, and once I bought in, I realized, okay, that has been not the smartest idea, but still, you got to do what you got to do.
For example, for me, it was a very awesome experience looking to 2.5 years back, because, well, doing something new is something every developer can do, but fixing stuff which is used, and yeah, it was really cool after the relaunch of the new website.
And also, I think one thing which all of you might know is the dealing with the code is the easy part. I mean, dealing with the human beings, dealing with the management, dealing with the people using that code, that was the difficult part, and that was also the most exhausting part.
So you mentioned 10,000 reads. So I wonder how this maps to visits or page views, because I guess that's the load on the database.
Yeah.
And 10,000 reads is quite a lot, so I would know the scale of the fan-in traffic, the user-facing traffic.
That was around like 3 million unique visitors a month, something like that.
Okay.
And for sure, I mean, the code wasn't done in a real optimal way, as you have seen. So there were a lot of unneeded reads and writes.
Okay, thanks.
More questions?
First of all, very impressive talk. My question is, how did you deal with the management? How did you get them to do the things that you asked?
In this particular case, I have been appointed by the VC, so that made my life a lot easier. But because for sure, as a normal employee, without having the backing of a major shareholder, you cannot just like exchange the management. I mean, you can try it, but most likely you exchange yourself then.
For example, I can give you an example. When adding a new payment method, that took us, I think, 5 months. So adding a new feature, which is not very complicated, 5 months, which is a no-go. And everyone saw it. We have to do the cut and do a lot of refactoring and do a fresh start of some things.
Yeah, and also in the management. Any more questions?
You told that the developers were sitting in own rooms. So did you change that too?
What do you think?
Yeah, sure.
For sure. The very first thing, actually, I took away the phones. And actually, that sounds easier, but I had to use a lot of pressure because the developers, they were happy. But all the people who were used to call them up and tell them like, oh, is this not working? Or I have entered that, and can you check, and so on, because they wasted like, for sure, 50% of their daily work with complete useless shit, yeah? And all these people were complaining, so I really had to use brute force, like no one is, and we changed the rooms, put them all in one room, removed the phones, so that actually helped a lot. Anyone? There. Here.
Do you have any idea, like, how does a company end up at such a point, like that you have all your developers like in own rooms, just doing shit? How do you avoid that? How do you come to this situation?
Well, again, phrasing Christian here, you just need smart management. And in this particular case, it was like 10 years of micromanagement. The more interesting question would be, why is such a company so successful? Because we're talking about a really successful company, yeah, still successful. So the question is how this can happen, yeah, and I don't have an answer on that. I really wonder, because as an engineer, I always think like, oh, software has to be awesome. We need to do this and this and this. But I learned the hard way that with like really hacking and doing everything wrong, you still can be successful. One day it will hit you in the face, but that day can be very far in the future. All right, then. If there are no more questions, thank you very much. Thank you very much.